So we want to find the equation of the perpendicular bisector joining 2 points. So let's start off by doing a little sketch to see what we're looking for. Let's assume we've got one point A and another point B. So that could be our A and that's our B. And we want to just think of the line joining them, bit of a wobbly line, but you get the idea. And we want the perpendicular bisector of that line. So the bisector means it's got to cut it in half. So let's say the midpoint's around about there. Should we call that M? M for midpoint. And if it's got to be perpendicular, then that line is going to be looking something like that. So we're looking for the equation of that line. So that's going to be a right angle in there. So the first thing we're going to do is to find where M is. So that's simply the midpoint of the 2 points. So we're looking at A and B and finding the midpoint. So we're really averaging each of the coordinates, the x coordinate and the y coordinate. So looking at the x coordinates of A and B, we've got -1 and 3. We want to know what's halfway between those. So the general method here is to add together the coordinates and divide by 2. And we do the same sort of thing for the y coordinates, the -2 and the 6. We want to know what's halfway between -2 and 6, so add them together and divide by 2. And so that gives us the x coordinate is going to be 3 minus 1 is 2, 2 divided by 2 is 1, and the y coordinate 6 minus 2 is 4, divided by 2 is 2. So the midpoint, our M, is the point 1, 2. So we've got a point on the line, so that gives us this point M. We know what that actually is, and now we just need to find the gradient of the line. Now you're probably used to using the notation of a little m for gradient, so let's say the gradient of our original line joining the given points is m1, then the gradient of the line that we want is m2, and I guess you know this formula that if we've got two lines that are perpendicular to each other, the product of their gradients is going to be -1. So we should be able to write down the gradient of the line that we're given, so that the line that we want, we're going to be able to find that in terms of the gradient of the line we're given. So in other words, M2 is, let's put the minus up there, -1 over M1. So once we found the gradient of the line AB, then the line of the line we want, the gradient of the perpendicular bisector, is going to be the reciprocal, well, the negative reciprocal, isn't it? Let's see how that works. So M1 is equal to the difference in y coordinates, so 6 minus -2 divided by the difference in x coordinates, so 3 minus -1. So that's 8 over 4, so that's going to be 2. So our other gradient, the perpendicular gradient, is going to be -1 divided by that, so it's -1/2. So we now have enough information to write down the equation of the line that we want. So let's use the formula y minus y1 is m multiplied by x minus x1. It's not the only way of doing it, but it's fairly straightforward in this case, isn't it? So we've got the point m, 1, 2, and the gradient also m is -1/2, but the values here are going to be put in first of all from the point. So y minus 2 is -1/2 times x minus 1. And we could simplify that, so we could start off by just multiplying out that bracket, so -1/2x plus 1/2, and then if we add the 2 onto both sides, we get -1/2x plus, so we could either write 2.5, or better really to write that as a top-heavy fraction. And then checking it, we'd want to make sure that the gradient is perpendicular to the other one, which that's straightforward, it is, isn't it? Because the product of 2 and -1/2 is 1. And then when we substitute our value for the point M, the midpoint, let's see what happens. If we put x equals 1, our y turns out to be -1/2 plus 5 over 2, which is equal to 2. So that gives us the right midpoint. The other thing that you could do is actually plot the points and plot the midpoint and actually draw in the perpendicular bisector and see if this turns out to be correct.